So if you're going to set u equal to 2x, du will be 2 dx. And dx will be du over 2.
I have a dream, that's all I need. I'll make it happen with some work and belief. Know what I want.
Hello guys, what's up? Welcome back to my YouTube channel, Mathematics TV. So today is another tutorial day. So now I'm going to show how to integrate integrals with trigonometric functions. So first, if you're going to integrate integrals with a trigonometric functions, you need to familiarize all of the trigonometric identities. So my technique in integrating trigonometric identities, which is if you're going to integrate integral of sine mx times cosine nx dx, so here's my technique. If I notice that the power of sine and cosine x are both odd, which is the power, or the m and n are both odd, use the Pythagorean identities, which is sine squared x plus cosine squared x equals to 1. So if the power of them are both odd, you can apply it for sine x. You can apply also for cosine x. Therefore, the answer will be 2. So for the case 1, you can apply the Pythagorean identities in sine x. So the answer will be different if you apply the Pythagorean identities in cosine squared x or in cosine x. And the second one, if the power of sine x and cosine x are both even, use the half angle identities, which is for sine squared x is equal to 1/2 times 1 minus cosine 2x, and for cosine squared x, that will be equal to 1/2 times 1 plus cosine 2x. So let's try some example. So if we have a problem, integral of sine cube x dx. So what you need to do is apply these identities, or apply the Pythagorean identities if you notice that the power is odd. So this can be rewrite in integral of sine x times sine squared x dx. So this is still the same. Now the value of sine squared x is equal to 1 minus cosine squared x using Pythagorean identities. So this will be integral of sine x times 1 minus cosine squared x dx. Now you can put the value of or this can be done using a simple substitution by putting u equal to cosine squared x. Then the derivative is sine x. This is sine x. So if I will set the value of u equal to cosine x, the du should be, or the derivative of cosine x is negative sine x, and the dx will be du over negative sine x. So let's substitute this value into the problem. So the integral now will be integral of sine x times 1 minus cosine squared x, which is u, so this will be u squared, times dx. If you're going to get the value of dx, just divide both sides by negative sine x. So this will be cancelled, and the d will be negative, or the dx will be du over negative sine x. So times du over negative sine x. So if you notice now that the sine x will be cancelled out, and there's a negative here, So don't worry, you can put that before the integral sign. So this will be negative integral of 1 minus u squared du. And this is very easy to integrate now. You can use the power formula in integrating 1 minus u squared. So for the integral of 1, that should be u, since with respect to u. So integral of 1 is u minus integral of u squared is u cubed over 3 using a power formula. So this will be u cubed over 3, then plus the constant. But there is a negative here. So this should be negative u, then positive u cubed over 3. But the value of u is cosine x. So our final answer will be negative cosine x plus cosine cube x over 3, then plus the constant. So this is the final answer. So for the second example, so this is the first example. So for the second example, if we're going to integrate sine, let's say sine squared x dx. So if you notice that the power of sine x is even, so use the half angle identities for sine squared x. So this will become integral of 1/2 times 1 minus cosine 2x, then times dx. Now this will be easy to integrate because this is equal to integral of, or 1/2 integral of dx. I will just split the integral, so distributing the 1/2 here. So this will be 1/2 times integral of dx minus 1/2 integral of cosine 2x dx. Now this is very easy to integrate, as I said. So this is equal to 1/2 for the integral of dx is equal to 1/2 x minus 1/2 integral of cosine 2x. So what is the integral of cosine 2x? So if we're going to set the value of u equal to, let's apply simple substitution integrating cosine 2x. So if you're going to set u equal to 2x, du will be 2 dx, and dx will be du over 2. So if you plug in this value into the problem, this will become integral of 1/2 times 1/2 here. So this will be 1/4 times the integral of cosine u, which is sine u. But what is the value of u? U is 2x. Hence, our final answer will be sine 2x, since u is 2x. So then don't forget to add the constant of integration, which is c. So we're done, and this is our final answer. Alright, that's all for today, guys. Thank you so much for watching, and please share your thoughts about it by commenting below. And if you learned something today, please give this video a thumbs up. Also, if you want to see the other videos, link in the description below. And please don't forget to subscribe and click the notification bell. Stay tuned and see you on my next video. Thanks and God bless.
I have a dream, that's all I need. I'll make it happen with some work and belief. Know what I want, so I'll take it on. I've made mistakes, but mistakes make you strong.